Okay, so in the first video, we went over what a piecewise function is, which a piecewise function is just a function of two or more parts or pieces. That's all it means. So don't make this harder than what it is. We talked about how to evaluate a piecewise function, so we just did number one. So for the rest of this video, we're just going to be graphing. Okay, so like I said, if you know how to graph a piecewise function, then you're good. You don't need to watch the rest of this. If I would go through and double check that you're getting the same things and see if you're all right with that. Okay, so I'm going to jump to number 3. We're going to graph a piecewise function. And we have on number 3, always identify how many parts you're going to have. So on number 3, we have 2 parts. We have the top line represents the first part. I'm going to highlight 2 things in that top line. One thing tells us what we're going to use. One of them tells us what our function is. The other says what we can use. Okay. So this right here tells us the numbers I can use. So it tells us what we can use with negative 2x plus 1. Okay, so this right here tells you what numbers you can put into negative 2x plus 1. So this says, hey, when x is greater than negative 3, I can put bigger numbers than negative 3 into this problem. If they're bigger than negative 3, I can't put them into the yellow because this goes and tells us what I can use. Okay, it's just a list of rules. You just got to follow your rules so you know which ones to graph. Okay, D and R represents domain and range. We're going to create our graph first and then we'll do that. So here's what I'm going to do. When I graph these, what I do is I create 2 because I have 2 pieces. So one of them is going to represent x. I'm going to create a table. The other piece is going to represent negative 2x plus 1. I'm going to create a table. And we're going to start putting numbers in our charts. And we're going to graph these. Okay? Now, here's what I do. These tell us where our graphs are going to start. Okay? So this graph, x, is going to start at negative 3. And I'm going to use numbers less than negative 3. So what kind of numbers are to the left of negative 3, negative 4, negative 5, negative 6? Do you have to use all those numbers? No. Use as many as you need. When you guys create a graph, use as many as you need. Okay? When they create highways in the city, they make how many? As many as they need. So how many dots do you need? That's up to you. You need more than 1. Do you need 2? Do you need 3 to know where the graph's going? Okay. Now, what are we going to do? Wherever x shows up, so here's the function. Wherever x shows up, you're going to create a set of parentheses, and we're going to put negative 3 in there. And in fact, if you want to make it 1x because you need the number out front, you sure can, if that helps you. I don't know. I don't know what you need. Okay. I'm here to help, so if you need help, that's what you need to tell me. But the first thing I'm going to put in for x is the first number is negative 3. So what is negative 3 times 1? Negative 3 times 1 is negative 3. The next number, 1x, put a set of parentheses where x is. What's the next number we're going to use? We're going to use negative 4. 1 times negative 4 is negative 4. What's the next number? 1x. What are we going to put in for x on the next number? Negative 5. 1 times negative 5 is negative 5. And I looked ahead. There you go, silly old man. And I'm going to go 1x. Wherever x is, we put a set of parentheses. What's the next number we're going to use? We're going to use negative 6. 1 times negative 6 is negative 6. This is what you are going to graph. Okay? So what you need to remember is you need to remember that this is where your graph starts. Your graph starts at negative 3. So we need to go plot that first dot. So can we go plot that first dot together? Go to the left 3 and down 3. So 1, 2, 3, 1, 2, 3. Okay. Where's my next dot? Now, you know what? I'm going to put my next dot in orange because I want to make this visual. Go back 4 and down 4. I should say go to the left 4 and down 4. 1, 2, 3, 4. 1, 2, 3, 4. You plot these like points that you did in middle school, in Algebra 1 and pre-algebra, wherever you were plotting points. These are still plotting points. Go To the left 5 and down 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Go to the left 6 and down 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay? All right. Here is piece number 1, or part 1. This is part or piece number 1. It's right here. Now, did you see the first graph or the first dot that I made? Was the dot at -3. I haven't put it in a different color. Okay? So what we're going to do is we're going to connect these. All right, everybody, put your pen or pencil on your starting dot. Do you notice how my starting dot here is I put it in a different color so I could see which one's different than the other? Put your pen or pencil on the starting dot and connect the rest of them. Follow it. Well, we know it's going to be a line. It goes that direction. Put an arrow on it because this line doesn't stop going that way. This is where the grind starts. We follow it. It keeps going that way because there's no stopping sign on this. So this is your first piece or part. It doesn't extend across the whole graph. Did we make any dots over here? We didn't. So that's how a piecewise function is different than a regular graph, because a piecewise function has a chunk of the whole thing. It's not the whole line. It's a piece of the line. When they make a road or a highway in the city, it stops somewhere. Okay? When we drive down Craig Road or Ann or whatever in Las Vegas, those roads don't go on forever. They stop at some point. They stop. They stop. So this road stops right here, or starts, however you want to look at it. But either way, I called it start because I put my pencil here first, or pen, and I followed those dots. I connected them. It doesn't stop over here. Okay, and in fact, 1, 2, 3, this is -3 over here. And I'll show you what else I do usually so you guys can see where we're at. So there it is. Okay, there's part 1. Now, let's go graph part 2. This over here is going to be part 2. This is going to be the second part of your graph. This is going to be the second road on your highway system. So what's the first number we're using? Okay, it says x is greater than -3. What is the first number bigger than -3? It's not -2. Okay, it's actually -2.99999. So what we're going to do is we're going to cheat here a little bit. We're going to use -3 to start with. So we're still going to start with their numbers. We're going to use -3 on that one as well. And we're going to use numbers bigger than -3. So what are some numbers bigger than -3? -2, -1, 0, blah, blah. If you don't like negatives, what else could you do? Could you use positives? You can. So maybe you want to use 0. Maybe you want to use, I don't know, 4. It doesn't matter. But whatever numbers I pick in this, what do they have to be? They have to be bigger than -3. So we have to use numbers that are larger than -3. Did I pick -3? Did I pick numbers larger than -3? 0 and 4 are both larger than -3. Okay? What are you going to plug them into? You're going to plug them into -2x plus 1. But where -2x plus 1, wherever x is, -2x plus 1, wherever x is, -2x plus 1, you're going to put a set of parentheses. And what's the first number we're going to use? We're going to use -3. I know some of you right now are probably yelling at the screen. You're like, why are you using -3? It's got to be bigger than -3. I know. We'll talk about that here in a second. Don't be mad at me. Don't get angry. Don't get riled up over silly stuff. I'll show you why. -2 times -3 is 2 times 3 is 6. And 6 plus 1 is 7. So -3 is going to give me 7 back. The next number I'm going to use is 0. 2 times 0 is 0. 0 plus 1 is 1. -4, or positive 4, excuse me. Make sure I know what I'm saying. -2 times 4 is -8. -8 plus 1 is -7. Okay, so when I put 4 into that, I should have a -7. Okay? Okay, so there's your numbers. Understand how we got those. Okay, now, I know what we said. These numbers have to be larger than -3. But I didn't want to use negative 2.99 because technically that's the first number that's larger than negative 3. So what we kind of do here is we kind of cheat this. Okay? We kind of say, yeah, we're not supposed to be using negative 3, but this is what we're doing. So I'm going to graph this dot first, negative 1, 2, 3, and I'm going to go up 1, 2, 3, 4, 5, 6, 7. But rather than putting 2, 3, 4, 5, 6, 7, rather than putting a regular dot on it, I'm going to put an open circle on it because what that represents is it doesn't really go there. Okay? It's not really negative 3. But it saves us hassles that rather than using negative 2.99. Okay? You guys ever see on TV where they sell stuff and it's like $19.99? It's not really 20 bucks. Everybody's going to call it 20 bucks. Like how much did it cost? It was 20 bucks. But it's not really 20 bucks. It's $19.99. Okay? So we're not really supposed to be using negative 3, but we're going to start at negative 3 just because it's much easier to use than negative 2.99. Just much easier to say than $19.99. We'd rather just say 20 bucks. Okay? Let's graph our other dots. I'll put them in a different color. 0 and 1. 0 and 1 is right here. To the right, 4 down 7. 1, 2, 3, 4 down. 1, 2, 3, 4, 5, 6, 7. Okay, let's look at our graph. Okay, which one are you going to start at? You're going to start at this one. You're going to start at the negative 3, 7 dot. And in fact, we know which one that is. That's right here. Let's grab a different color. We're going to start there at the open circle. And we're going to connect our other two dots. And there we are. There's your piecewise graph. You have two portions that make up the whole thing. Okay, where is that graph split? The graph is split. I'm going to highlight that spot. That graph is actually split at negative 3. Does everybody see at negative 3? That's where the graph's kind of broken. Could we have told you that before we even started? Yeah, right here. I know the graph's broken at negative 3 because if you look at this, both graphs have something to say about negative 3, so I knew there was going to be an issue there. So that's where the graph's broken up, is at negative 3. Okay? So here's what I want you to remember. Okay? If it uses a less than or equal to or a greater than or equal to, use just a normal point. If it's greater than or less than or greater than, then what I want you to use is I want you to use an open point. Use that. That's what we did over here on your graph. Okay? Notice, when x was greater than negative 3, that's where you used the open point right there. Okay? All right, so that was number 3. Let's graph number 5. And then we'll look at 7. Oh my goodness. 5 I already see has a fraction. It's okay. It's all right. We'll be able to handle that. Okay. Now, hey, what do I notice? As we get better and as we get faster at this, where is this graph going to be split up? Well, you know the first graph is going to use this. X equals a negative 1/2 x, or x equals negative 5/2 x minus 1, for all the numbers that are less than 2. We're going to use x plus 2 for all the numbers that are greater than 2. So instantly, what do we know? Where is the graph split up? The graph splits up at 2. So when x is 2 over here, 1, 2, when x is 2, what you're going to have is that's where things are going to be changing. That's where it's going to go from one side or the other. So this graph lives on the left of 2. I should look at the right graph when I do this. So here's 2. My yellow highlighter is dying on me. So this graph lives on the left of 2. How do you know it lives on the left? Look, because it says less than 2. So less than means to the left of 2. So this graph right here, the negative 5x minus 1, it'll live in this yellow region. a lot of times when we're in class, this is what I have kids do. I have them graph highlighters or grab highlighters, and when they graph, I have them highlight where is that portion of that graph going. This orange portion, he's going to live on the right of 2 because that's what greater than means. So I'm going to color the right of 2, which is everything over here, and we know that that graph is going to live in that part. Okay? Just like if I went back to number 3, and we said 2x plus 1 or negative 2x plus 1 will be on the right of negative 3. If I shade the area where it should be living, the side of town where it lives, is its graph in that piece? It is. When I shade this, x is less than negative 3. So 1x, its graph should be on the left of that dividing line. Do you see the two portions? Do you see that? They're going to live in those spots. They're going to live in those places. Okay? So really, all you need to know is where the graph lives and where it is or where it isn't, and then you're going to be able to know where it starts and doesn't start. Okay? So negative 5 halves x minus 1 is going to be one of them that we're going to do. We're going to do x plus 2. That's the other graph we're going to do. What do both numbers start with? They both have 2 as their leading candidate to look at. So we're going to look at both of those. XY, XY. This one says less than 2. So when x is less than 2, what did we just say on the last page? This one's going to be an open dot. This one says when x is greater than 2, so he's also going to be an open dot or open point, whatever my wording was on that last open point, I guess is what I would have said. Okay? Because technically, what's the first number bigger than 2? The first number bigger than 2 is not 3. I know that's what a lot of people think. What's the first money amount that's bigger than $2? It ain't $3. $2 and a penny is bigger than $2. But I don't want to use 2.01 here. So let's just cheat it a little bit. Let's just call it 2 and then put an open dot there. Okay? All right, on the negative 5x minus 1. What numbers can we use? Any numbers that are less than 2. So pick any numbers here that are less than 2. That's what it tells you can use, is numbers less than 2. So, kids, you can pick whatever numbers you want. You just got to follow the guidelines that they got to be less than 2. So for me, when I do problems like this, what's an easy number that's less than 2? The easiest number for me, now you may think something else is easy. Pick what's easy for you, but the easiest number for me is to pick 0. Is 0 less than 2? Yup. Okay. Now you can plug those in, and we can plug those in for x. So I'm going to get negative 5 halves x minus 1, negative 5 halves x minus 1. Can you keep going? Yeah, but kids, you already know this is going to be a line. So how many dots do you need for a line? I need 2. You need 2. I mean, you can make more if you want. So let's put 2 in there. Okay, you ready? Here it goes. We got fraction work here. Don't relax. What's 5 times 2? 5 times 2 is 10. You see how I did that? Parentheses, side by side. So 2 times 5. Doesn't go to both. It goes to one, or so it goes to the, I should say it goes to the top, because 2 times 5 is 10. There you go. And what does a fraction mean to do? It means to divide. Negative 2 or negative 10 divided by 2 is negative 5 minus 1. So that's going to be negative 6. Next number we're going to use is 0. Hey, what's 0 times anything here? 0. And we're going to get 0 minus 1. What's 0 minus 1? Negative 1. Okay. So let's go plot these two dots. So at 2, negative 6, go to the right 2 and down 6, to the right 2 down, 1, 2, 3, 4, 5, 6. We're going to put a dot there. What kind of dot? Open, because it was just a regular less than. And if you don't remember, on the last page, we just talked about that. If it's a regular less than, use an open point. Open dot, open point. Go plant the other dot. 0, negative 1. That means don't move any left or right. Go down 1. Do you see where your graph goes? This graph only lives where? This negative 5x minus 1. In fact, I highlighted that in yellow. So your only bit or piece should just be in the yellow portion. So don't cross over to the dark side. Don't cross over to orange. Go strictly to the yellow and stop where the break line is. Okay? So often kids want to go all the way through. Remember, this is a piece of it. It's not the whole thing. If you have a candy bar and I say, hey, can I have a piece of that? You're not handing me the whole candy bar. You're breaking off a piece of that for me because you love to share. So this is a piece of the whole line. It's not the whole line, so it doesn't keep going. How do you know when to stop? This tells you where they start and stop. Look where they're broken up. They both share 2, so 2 is where they're going to be broken up at. All right, x plus 2. X plus 2 uses numbers that are what compared to 2? When x is, that's a greater than. So we need to use numbers that are greater than 2. So if we use 2, what's the number bigger than 2? 3, 4, 5. I don't care what you use, just use numbers bigger than 2. You're going to put that into the equation, x plus 2. So x plus 2. X plus 2, x plus 2. So when I put 2 in, 2 plus 2 is 4. When I put 3 in, 3 plus 2 is 5. Could I keep going? I sure could. 4 plus 2 would be 6, and I think you get it. But how many points do you need? 2 or 3? That's all I need. If you need more, you can make more. Be an overachiever. Go to the right 2 and up 4. Go to the right 2 and up 1, 2, 3, 4. What kind of dot are we going to place on that break line? 1, 2, 3, 4. An open dot. Go to the right 3 and up 5. There's 3. 1, 2, 3, 4, 5. And go to the right 4 and up 6. 1, 2, 3. Oops. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Do you see where that picture of that graph goes? Where is that graph going to start and stop? This is in the orange section. So when you go to connect your dots, don't put any of that graph. Do you see how the graph, its dots are in the orange section? Don't cross over to the dark side over here. Put your graph strictly in the orange section. So that means when you connect your dots, because it's a piece of it, put all of your graph in the orange section, put an arrow on it to say, hey, I live over here in the orange section. Don't put an arrow on this end. If you put an arrow on this end, you're telling me he goes that way. Remember what arrows mean. Arrows mean it's headed there. So if you put an arrow on the end of this, it means you're telling me you're headed in that direction. There is no arrow on this end because it stops here. This is not its part of town. It lives in the orange. This part lives in the yellow. Okay. Like I said, if you got issues, let me know. Piecewise functions get a little shaky with people, so if you're confused on anything, don't feel bad. Just let me know. Okay. I'm going to start with that one, and I'll make a video for, excuse me, I'll make a video for number 7.